Okay, I've talked a lot about heat, but I haven't defined heat yet. So let's do that in this video. And so in the 1840s, James Joule, he did this experiment. He had some water and then he hit the water and he realized that the temperature increased. Then he took a spinning paddle here and then he spun this thing, right? And so while he was doing that, he was doing work because you have to do work to spin this paddle. And what he realized is that the temperature again increased. So therefore, here you have heat and it produces an increase in temperature. And here you're doing work, you're doing physical work, you're spinning this paddle, and you also increase the temperature. So what he realized is that heat and work, uh, which were previously regarded as completely different phenomena, he realized that there are simply two different ways of transferring energy to or from a system. So when you heat a system, you're basically transferring energy from the environment to the system. When you do work, you're transferring energy to the system too. So therefore, thermal energy is so let's define a few things here. Thermal energy is the energy of the system due to the motion of the atoms, right? You can think of a system as composed of molecules or atoms, and these molecules are vibrating or moving at different speeds, and that is your thermal energy. Heat, which we denote by Q, is energy transfer between the system and the environment or between systems, right? So heat is basically energy in motion. Temperature. Temperature is a state variable that quantifies hotness or coldness of a system. You require a temperature difference for heat to be transferred. So let's look at this table here. If we have a positive heat, that means that energy is being transferred to the system, right? So the temperature of the environment is greater than the temperature of the system. If we have a negative heat, that means the system is losing energy. Energy is being transferred from the system to the environment, and the temperature of the system is greater than the temperature of the environment. When we have thermal equilibrium, both temperatures are equal and there's no energy transfer. Q is equal to 0. So here is another way to look at the two types of ways of transferring energy to a system. So we can transfer energy to a system by doing work or by heat. The type of interaction in the case of work is a mechanical interaction. In the case of heat is a thermal interaction. This work requires force and displacement, right? You have to push, you have to pull, and something have to move. Heat requires just a temperature difference. The process that produces work is basically forces, pushes and pulls. The heat, the process that produces heat transfer, is basically microscopic collisions of the atoms. So a positive work, W greater than 0, means the gas is being compressed, the energy is transferred in, the energy of the gas is increasing. A positive heat means the environment is at a higher temperature than the system and the energy of the system is increasing. Negative work means the gas is expanding. Energy is being transferred out of the system. Negative heat means the system is cooling. The system is at a higher temperature than the environment and energy is being transferred out of the system. During equilibrium, if there is mechanical equilibrium, well, there's no forces acting on the system and the system is not moving, nothing is changing mechanically in the system. And a system in thermal equilibrium means the system is at the same temperature as the environment and the heat is 0. So some comments about the Unix. Unit heat is just energy being transferred, therefore the units of heat are the same units of energy, which is joules. Historically, a unit for measuring heat, the calorie, had been defined as 1 calorie is equal to the quantity of heat needed to change the temperature of 1 gram of water by 1 degree centigrade. That is a definition of heat, and we know today that, well, these are energy units, so we can do a conversion between calorie and joules, and 1 calorie is 4.186 joules. The calorie that you see in the food labels in the grocery stores, that calorie is actually 1000 calories, is 1 kilocalorie. So let's look at here, let's look at heat and work again. So I have a system here. This system is at 306 Kelvin. So now I want to, and this system has some energy. So I want to change the energy of this system. I can do that in two ways. I can do work or I can heat the system. So let's increase the energy of the system by doing work. I'm going to push and compress the system. When I do that, the energy is increasing. You can see that the temperature increases when I compress the system. Now, I'm going to decrease the energy of the system by doing work. The system has to push something, has to release energy by pushing something, so the system expands. When the system expands, you can see the energy decreases. Now you can change the energy of the system by heat. You can add heat to the system. And you can see that when you add heat to the system, the temperature increases. Or you can cool down the system. You can have the system release heat, and that cools down the system and the temperature decreases. So to summarize, you have work, you have heat. If you do work on the system, if you compress the system, the energy of the system increases. If the system does work, the system expands, the system is pushing something, the energy of the system decreases. If you heat the system, the energy of the system increases. If you cool down the system, the energy of the system decreases. Increasing energy means increasing temperature. Decreasing energy means decreasing temperature.